Hello and welcome everyone to this session, ArcGIS API for JavaScript Data-Driven Animations. My name is Christian Ekenis. I'm presenting alongside my colleague, Anjul Batsuk, and we are very excited to discuss this topic with you. It's a very exciting one, and I think it's fascinating, and I'm excited to see what you guys can do with data-driven animations in your own apps. So I just want to show really briefly the types of things we'll be covering. We're actually going to break down data-driven animations into three different types. There's the data filter animation, there's visual variable animation, and data variable animation. And they all deal with animation, they all deal with data. It's just that they are all distinctly different. So I'm going to now turn it over to Undrul, who's going to talk about data filter animation and the types of data sets involved with that.
Hi, this is Andrel. So in this section, I'm going to talk about how to do a data filter animation. So you can animate through your data by filtering your data based on their attributes or a given geometry or time extent. You're not changing the layers render as you're animating through the data. Instead, we are animating the data by filtering out the features that does not meet the specified requirements. So we're going to talk about all those three ways of filtering your data. First, we are going to talk about how to filter the data based on time. Temporal data allows you to detect and visualize change or pattern emerges over time. So as you're animating your data over time, the locations of the objects could be changing on the map. So examples of the moving objects include airplane and vehicle tracking, smoke, storm and hurricane tracks, or in this case, we're looking at the smoke forecast data. Also, when you're animating your data, the geometries of your features could be changing over time, whether it's growing or shrinking or moving around the data. So such examples include land use change or urban area growth, or in this case, the fire perimeter change over time. Also, with the temporal data, as you're animating your data over time, the objects are stationary on the map, but the attributes that describe the objects are changing on the map over time. So the examples include discrete events like earthquakes, accidents. Also, the data could be coming from the sensory data like stream gauges or weather station data. Also, maybe the characteristic variables that describe the data could be changing over time. The example includes the US population change by US counties over 100 years. So when you are creating a temporal data based on a stationary object where the attributes are changing, what we need to do is we need to duplicate each feature for each unique date. So going back to the example of the US counties, right, we have to duplicate the US counties geometries 100 times to show the population change for every year. So if you're talking about the large data set over a long period of time, you can see the data can get really large and bloated really quickly, and this can negatively influence the performance of your JavaScript applications because we have to fetch a large data set over the network. So Christian will show you how to handle this scenario more efficiently, so stay tuned for that. Okay, so you can use time slider widget to animate through your data as long as it has time information. So the time slider widget, it makes the time animation or temporal animation simpler for the developers. So you can use the time slider widget two different ways. Okay, so first, animating the time-enabled services. ArcGIS services like map, feature, and image services can be published with the time info. So in this screenshot here, we're looking at our smokes forecast feature service endpoint, which was published with the time info information. You can see in this screenshot here, the time extent spans about 48 hours or 2 days, and then the time interval is 1 hour. So this data gets updated every hour. So we can add this feature service to a Forex application and animate through the smokes forecast data. So to do that, we're creating a new instance of a feature layer to point to our smokes service. Then we're creating a new instance of a time slider and setting a bunch of properties on a time slider. But one property I want to talk about is a view property here. So we're setting the view property on the time slider widget. And because the service has a time info information, we can ask that view property to filter out the data from the service if they don't fall within the current time extent of the time slider. Okay, so in this case, the view is filtering out the data, and you as a developer, you don't have to write the logic to filter out the data as the time slider's time extent changes. Also, when you're adding the time slider widget, you always have to set the full time extent on the time slider widget. This property specifies the entire time span of the time slider widget. And then also we're setting the stops property to match the service's time interval information. So as you can see here, from the layer, we're getting the time info property, and then time info property as a full time extent and interval properties. We're reading those values and setting the time slider widget's full time extent and stops to match the service's full time extent and stops. So when we run the application, this is how the time slider is going to look like. Okay, so if you are adding a client-side layers like CSV, JSON, or a client-side feature layer to Forex application, then you can set the time info property at the time of the layer's initialization. So when you're adding a client-side layer to Forex applications, at the time of the layer's initialization, the API will fetch all of its data at once and store it on the client side. So once the client-side layers are loaded, we don't have to make server-side calls to fetch the data. So because all of its data is available directly on the client side, the JavaScript API will allow you to set time info properties for client-side layers as long as the data has date field. So in this example here, we're creating a new instance of a GeoJSON layer, adding a USGS earthquakes data, and the earthquakes data has a date field called time. So we're setting a time info property here, setting the start field to the date field, and setting the interval to 1 day. Then we are creating a new instance of a time slider, and we are setting the view property. Because our layer has a time info property, the view will be able to filter out the data from the GeoJSON layer as the time slider's time extent changes. So it's a demo time. Let's take a look at how to consume time-enabled services in JavaScript application. Okay, so in this first demo, I'm going to use the Smokes Forecast feature service. And this service is published with the time info information here. You can see the time extent and then also the time interval information for the Smokes Forecast. You can see from the time interval that this data gets updated every hour, and the entire time span extends for 48 hours. So here is the application that uses the Smokes Forecast data. I'm going to hit play on a time slider, and you can see the smoke forecast updating by hour for next 48 hours. Let's take a look at how this is done, right? So here's my smoke featured layer pointing to the Smokes Forecast feature service. Then we are creating a new instance of a time slider, and we are setting the view property here. Because the smoke layer has a time info information, we can set the view property on a time slider so that the view will be responsible for filtering out the data that doesn't fall within the current time extent of the time slider. Okay, and then also you have to set the full time extent, and also we're setting the stops property on the time slider. So here we're getting the smoke layer's time info information and populating this full time extent and interval properties, and both of those properties are available on the time info property of the feature layer. And then we are setting the full time extent and an interval to match the full time extent and time interval of the Smokes Forecast layer. So another thing I want to show is that, as you can see, the fires and the smoke layers have this smoky and the fiery feelings, and we are setting this through an effect on a feature layer. So we have an entire session that talks about how to apply Photoshop like visual effects to your layers to create really cool looking maps. So if you want to learn about effects and blend modes, the information is available at the end of the session. So what if your service doesn't have a time info property but has date field? You can still animate through this data using its date field with the use of time slider widget. So because the service doesn't have a time info property, you cannot set the view property on the time slider. But as a developer, you have to watch the time extent property on your time slider and write the logic to filter the data based on a date field. Okay, so in this demo, I'm going to use the 2019 Fire Perimeters feature service. And this feature service has a perimeter date time field, which is a date field, but it doesn't have a time info information published with it. So I'm going to use the perimeter date time field to filter the data as I play through time using time slider widget. So in this example, so here's the demo application. As I hit play, this time slider is showing the fire perimeter change for the Kincade fire that took place in Sonoma County in 2019. So here is the code. I'm creating a new instance of the feature layer, but also I'm setting a definition expression on my feature layer. I'm only fetching the fire perimeters associated with the Kincade fire. This fire, we're looking at the map here. Then we're creating a new instance of our time slider widget, and we're not setting the view property because our fire perimeter layer does not have a time info information associated with it. And we're setting the mode to instant because we only want to show the fire perimeter as is what recorded. Okay, so the instance basically matches the thumb. So we have a one thumb, and the fire perimeter matches the basically location of the thumb on the time slider. So then we are watching the time extent property, and when the time extent property changes, we're getting the time extent from the time slider, getting the start date from the time extent, which matches the location of the thumb, and calling the getTime method on a date object to convert this date to a Unix string, because our date is stored as a Unix string in this perimeter date field. Then we're setting a where clause. So I want to point out here, we are setting an attribute filter on our data based on our date field, okay? So then we are setting the filter object on the layer view and passing in our attribute filter. And later we will make sure, the filter will make sure that all the fire perimeters that does not fall within the time extent are filtered out. Also, the layer view represents the fire perimeters layer in the view, and layer view will give you access to all the features that are available for drawing on the client side. So whenever you're interacting with the methods and properties of a layer view, you're not making server-side requests to fetch the data. Instead, everything happens directly on the client side. So if you want to learn more about layer views or client-side layers, then we have a session for it. And the information for the client-side analysis is available at the end of the session on the slide. Okay, so we talked about how to filter your data based on date fields or time extents. Now, a few quick words on how to filter data by attributes or geometry. So you can filter your data based on their attributes by setting the layers definition expression, or you can set the layer views filter or layer views effect properties. Okay, so we have a lot of SDK samples to those, and check out the samples. For example, in this screenshot here, we're showing how to filter out the flash flood warnings by the season. This is an SDK sample. The link to it available at the end of the session. Same thing goes for the SDK sample for the filtering data by geometries. Okay, so in this example, you can see we are getting the flood layer view, setting the filter, and we're setting a where clause, which is an attribute filter. And season is the name of the field, and we are passing in a selected season, the season that user clicked on, and we're setting a filter on this data. So you can also filter the data by geometry by setting the layer views filter object or layer views effect properties. Okay, so with the filter, if you set the filter, then you're filtering out the data that doesn't match the requirements completely. With effect, all of the features are still visible, but you can apply two sets of effects to your features. If they meet the requirements, then you can set a included effect. But if they do not meet the requirements, then you can set the excluded effect on your effects. So let's take a look at this example here. This is an SDK sample too. We're setting a filter. We're setting a geometry. This filter geometry matches the purple geometry that we're showing on the map. Then also you can set the things like distances in units. So in this case, as user moves the slider over the slider, then we are setting the distance there. Then we are setting the layer view effect, passing in our filter. But in this case, we are setting an excluded effect. We are basically, if the features do not meet the criteria, we're setting 100% grayscale and 30% of opacity, and that's what you see on the map. Okay. So we have an entire technical session dedicated to client-side layers, client-side analysis, and we have a dedicated session on how to use feature filters and effects in that technical session, and that information is available at the end of this session. Okay. So this concludes my section of this presentation. Thank you so much for coming to our presentation, and I'm gonna hand the mic over to Christian. Christian?
All right, thank you, Andrel. Now we're going to talk about visual variable animation. Now this is, if you look at this image here, you definitely see a data-driven animation going on, and it looks sort of similar to what Andrel was showing you, but there is a distinct difference. So let's go ahead and dive into what that is. These types of animations are distinctly different from filtered animations based specifically on the fact that they involve fixed geometries and locations. So in the examples Andrel was showing you, you would see features appear as if they were moving, like the smoke example or hurricanes moving. It could be tracking devices. Those sorts of things really lend themselves towards data filters, what Andrel was showing. But there are cases where you have things like administrative boundaries, such as buildings, countries, states, county boundaries, that don't really change that often. And you just want to animate a data variable for that particular geometry over time or some other attribute. So you actually don't need to filter that data. If you were to attempt that with a filter, you would actually have to be downloading duplicate geometries depending on the unit that you're measuring by, or like the time extent. So if I wanted to show data for every year going back 100 years, I'd need 100 copies of each and every geometry. Not very performant. So that's why in this scenario, you can just have one row per geometry, essentially in your data set, and then you can update the renderer itself on each animation frame or slider change. So it's characterized by fixed geometries and locations, a fixed data variable, so it's usually a date field, but it could be something else, and I'll show examples of date and a non-date field, and changing visual variable stop. And it's also characterized by using just a single field or column in the table of interest. So I'll go ahead and show a couple of examples just so that this makes sense before diving into the particulars of it. Okay, so I've got a data set of New York buildings here. There's about just under 1 million building footprints. You can't really see anything in the view here because what I want to do is I want to animate when the building was built. And so I'm going to do that with a slider down here. This is just a regular slider from the JavaScript API. And this data dates back from 1880 all the way to 2017. And so I'm going to press this play button, and you're going to see these building footprints animate in, and they kind of have this cool flashing appearance when they are first built. That's kind of the effect we want to have here. So when a building is added, it's going to flash blue. This is a brand new building. And then as it gets older, it'll gradually transition to a purple color. So that's why you can see basically new buildings pop up in these later years here, but then you have the context of where existing buildings are and have been there for longer than, I believe, 20 or 30 years. So it's a pretty cool, flashy animation, and it tells a very particular story. So how is it that we actually accomplish this? Again, like I said, we're not doing a data filter here. These are all just building footprints. So what do we have to do? If I go back to my slide deck, so as I stated before, this is characterized based on one row in your table for one geometry and nothing more than that. So that's what you see here. We have, like I said, actually it's not just under a million. We have over a million features in this table. And the attribute that we really want to animate here is the construction year. And so you see that we have a field for that. And it's not a date field, it's just a number field indicating the year. That's why you see that odd formatting for it. It's just the default formatting in the table. And so we're going to use the renderer to our advantage to animate when a building was built and basically how old it is as well. So this is how it works. We have an animate function that is called every single time the slider updates. And what this does is it takes a value, and that value represents the year. So you have a starting year of 1880, and it can go up to 2017. And when the animation is called, we want to pass that year value to this set year function. And what that does is it's going to update some UI elements, but the most important bit is this right here. It's going to update the render. So we're actually creating a new renderer on our layer every single time that slider changes. And we're going to just focus on this part of the renderer. We have a field, it's a color variable, and then we have the construction year field that you saw in that table before. And then this value that is passed to that create render method is then used to calculate these color stops. So I want to point out a couple of really important things here. The first thing is this field doesn't change. So we're not talking about updating data. It's just a static table. Nothing is changing in this visualization. The other critical thing is that the color stops remain constant. I should say the color values in each stop is constant. So it always means the same thing. When you have a blue color, it indicates that that building was built for that particular year indicated on the slider. If it's a purple color, that building is 10 years older than the selected slider position, all the way up to 50 years older with a very dark color of purple where you can almost not even see it anymore. So every time that slider changes, you're going to see an update to the year. So let's go back and step through the code to see what that looks like. Okay, now I'm back in the app, and you can see the create render function here off to the side that's being called. So this year value comes directly from the slider. So you see the value 2001, and then you see it coming through here. I've added a breakpoint in here and pressed the play button, and we can step through it each time this slider value updates. So if I hit play, note that how that year updates. So it's really not that complicated. We're just taking a slider value and creating a new render using new data stops. And then it goes back to 1880 there. All right, well, let's take a look actually at another example. I said that it doesn't have to be a date field or an year. It could be something else. We actually have a precinct data from the 2008 presidential election. I know this is really old data. We could do 2020 if we had all the data for it, but it's not all been certified yet. So this is a really cool visualization because it shows a couple of things. It shows who won in a precinct, and then it shows the turnout. But then we're going to animate basically the visibility of the feature based on the margin of victory. So we have a slider down here that indicates if it was a contested election, all the way to if it was a landslide. So contested means that the margin of victory was 0 or they were tied, and landslide is 100% of the vote. So if I press the play button here, you can now animate from based off of, okay, at the beginning of this, it shows all the precincts where the election was contested. And then as it gets deeper into the slider, this is where these were precincts where almost all of the vote was cast for one candidate or the winning candidate. And I think this visualization is pretty interesting when you zoom into an urban area. So if I go to Seattle, let's go here. So these are the contested elections. You can see a couple of purple dots where there was an exact tie between Obama and McCain. But most of these others, the margin is so small, it's less than 1%. So I'm going to go ahead and hit play. And as you animate, you'll see a geographic pattern emerge, which is pretty fascinating. You see on the edges of town or in the rural areas, it's a little more contested. But as you get to the more and more, basically the landslide precincts here, they are very much in the inner city part of Seattle. And you see that pattern in other cities as well. So you can create some pretty cool visualizations to indicate some fascinating spatial phenomena. Again, you'd want to be pretty careful with how you do this because I think a lot of people might interpret the slider to be a time slider and it makes the visualization a little confusing. But as long as you properly communicate that this is to communicate a spatial pattern or a spatial trend, then I think this can be an effective visualization tool. All right. Now I'm going to go over another visualization technique, and that is data variable animation. Okay, data variable animation is very similar to this concept of visual variable animation. What I meant by visual variable is that you're changing some visual component of the symbol. So in that case, we were changing the stop values assigned to the colors, right? In this case, this is a little different. Again, we also have fixed geometries, so we're talking counties, states, administrative boundaries of some kind. It could be sensor locations if you're tracking some kind of scientific data. And it also involves an update of the renderer. But this time, the visual variable stops themselves are fixed. That means that the color values and the stops and the sizes, everything on the symbol, the render, everything, all the symbols on the render themselves are the same. And that is extremely important because that gives you a frame of reference to how the data is changing over time. This type of animation is characterized by the data variable updating. So now so in concept, what this means is that you have a data variable for today, and then you want to see how that same variable changes tomorrow. It could be temperature data like weather, it could be something like voting over time, or it could be population changes over time. I'll show you 3 examples, but just before we get into those examples, I want to emphasize that you're going to have multiple columns in each of these examples that you're going to basically switch the render to point. The render is going to switch to a different column depending on the position of your slider or the state of your app. So the column name is going to probably represent some kind of date value. It could also represent another dimension like a depth value. And the data structure we'll dive into as well after showing off these demos, but it's important to note that this requires one field per attribute per time interval. Internally, we call that a fat table because what it does is it increases the size of your table substantially going right to left. And you could make the table thinner if you use arcade expressions, and I'll show that technique as well. So let's dive into the examples themselves. So I've got an app here that shows temperature anomaly in different spots of the world, dating from 1880 to 2020, so just this last year. And so what this is doing is it will take the average temperature anomaly for that location, and I want to render that based off some kind of continuous color ramp. So if the temperature anomaly is below 0, it's going to be a bluish color. If it's warmer than 0 degrees Celsius, then it's going to be a reddish color. So I've hooked it up to this time slider here. And notice that as I move the slider, I get this nice animation that shows how a cooler world is becoming an increasingly warmer world. And you could see the histogram as well. So I'm going to kind of slow it down right here. You see the histogram indicate that that average anomaly is getting warmer and warmer each year. So all I'm doing here is I'm making a new reference. The render is pointing to a new data field each time this slider changes. I have a field for the temperature anomaly 1980, and I have one in 1982. So when I switch it, it's going to just switch to that value. And the render, all the other render properties remain the same. I've even added some interaction to this app. So when I look at these warmer years, I can click on the histogram, and then I'll see the corresponding values in the map that match those histogram values. And I could even update the slider to see if those same locations were cooler or warmer in different years. So it's pretty cool. Now I'm going to switch over to this app. This is an app I developed sometime middle of last year to track COVID cases in the United States. And so this follows a similar format. I've got one geometry, or I guess one feature per geometry. So there's 3,000 something counties in the US. That's all the number of features I have. And I've got some data values that give me a different look at how COVID is progressing or how it has progressed in the United States. And actually, when it comes down to it, and I'll show you this data in just a second. This data is really not that complicated. I just have one column per day, and the name of that field is the date. So this is the data for January 28th, but if I move it back to December 8th, this is what the data looks like. So it's pointing to a new data field. And that field, instead of containing a number, it contains a string that separates two values. It's the total number of cases reported separated by the number of deaths reported for that day. And so with just those two values, I can write an arcade expression to evaluate different variables on the client. So I can calculate active cases, or I guess I should say approximate active cases. I could check active cases per 100,000, so what's the rate? And I can also create a dot density renderer to show where are the cases more densely compact. And one of my favorites is doubling time, and I'll show you that one in just a second. But I want to show you the animation first. So if I start here, this was when the first case was reported in the United States, was in early, or I should say late January, January 20th. But I've pressed the play button on this time slider, and what this is doing is it's now animating how this variable has changed over time. So note the legend is static, nothing is updating there, and it's just the data. You can see the total numbers off to the left, and you can see how the percentage of people currently with COVID has changed drastically by geography over time. So it'll stop at the end, and let's look at the doubling time one. Doubling time, simply put, is it tells you how fast is the virus spreading. So is it going faster or slower? And basically the faster it spreads, or the faster it doubles rather, the worse off the area is. So in this color ramp, I have, if the feature is purple, it means that the virus is spreading at a fast rate. It's doubling every 7 days or less. And if it's this white color, then it means it's doubling. It takes more than 60 days to double. So if I start the animation over, now you'll see kind of these dark purple areas just all of a sudden show up in New York City, Chicago, LA. And then you see that it kind of fades out a little bit. That's because the virus started slowing down in those areas, but then it starts to speed up in other areas, like in the deep south. And you kind of see the ebb and flow of the spreading of this virus with this render. The size indicates the active number of cases. So how many people are infected at that time. So you see the Midwest light up right there, and now Los Angeles at the beginning of the year. And now everything as of the time of this recording in January 28th, everything is starting to slow down a little bit. So that's a good sign. And let's take a look at one more example. So this is an app I created using EMU data. EMU just stands for Ecological Marine Units. It's measurements in the world's oceans for various attributes. So we have in this app specifically temperature and salinity, but it also does other things like silicates and phosphate and other oxygen, other variables like that. But I just decided to use salinity and temperature. So I've rendered salinity here on a point layer. It looks like a raster layer, but it's actually just a bunch of points. And if I switch to temperature, you can see what the temperature of the ocean is on the sea surface. I added this depth slider here, and this allows me to see how that temperature changes by depth. So you can actually animate not just by time, but by Z values, right? This is my favorite view, is when I show the ocean currents, because you can see how temperature varies along the various currents. And if I zoom in here to these equatorial currents, we actually can get a pretty cool view as we animate the depth here. So I'm going to just move this slider, and you can see that not only does the temperature get colder as you get deeper, but the direction of the current actually reverses. And I can update this with very fast performance, so up to 60 frames per second. So you can create some pretty cool visualizations using this technique. All right, well, let's dive into the data behind each of these. So there's three, basically each of these apps follows a slightly different data structure. This temperature anomaly one is characterized by one column per time interval. So you'll notice these column names represent the year. So I have a measurement for 2011, one for 2012, 13, so on throughout the entire data set, dating back to 1880. And when the slider updates, so if you recall, I had an update render or a create render method in that New York buildings example. The characteristic of this is that instead of updating those color stops, all you have to do is update the reference to the field name in the variable that you're rendering on. So I'm rendering based off of a size variable and a color variable, and I just want to change that field. Nothing else is going to be different. So I'm going to clone the renderer, change the field on my color variable, and I'm going to keep all my settings, because if I change the colors, then all of a sudden the comparison between years no longer makes sense. It's really critical that those color stops remain the same. So this is the ocean data now. This data structure is characterized by one column per dimension per attribute. So if you look at this highlighted section here, we have one column per attribute. So we have salinity, we have the direction of the current, we have the velocity of the current, we have the temperature, and then it's appended with a number, and that number represents a depth value. So when the slider changes, that number is actually going to update based on the slider position. So here's how I built the renderer. It's a simple renderer, and it's got three visual variables. One for color, it represents the temperature at the particular depth level. So if you see this temp underscore, that's this field here. And then how do I know which of the temperature fields do I get? I get it from the depth slider value itself. So if it's in the first level, then I'm going to read this column. Once that slider updates, it's going to update to a new temperature column. Same with size. I have a velocity attribute here. This indicates the size of my point, and the rotation, of course, is based off of this direction here. So when that temperature attribute is selected and the direction and velocity attributes are toggled on, this is what's happening. And every time the slider changes, this renderer updates to point to these new fields. And so something that a lot of people have brought up is, well, that's fine and great, but my data isn't in that format. We typically have a table for geometries and then a related table for the measurements. Well, you can work with that. You do have to restructure your data to really take advantage of this technique. What you do is you need to make sure that you only have one geometry per location, And you can then perform a table pivot to pivot it from a really long table to a fatter table. And you just have to follow a schema that makes sense for your app. This is what made sense for this particular app. And so the benefit is you actually reduce the number of geometries that you download to the client, but it also does increase your attributes significantly. Overall, though, your download size is still reduced, so you're going to improve your performance if you want to do it this way. And then this is the COVID example. This shows multiple values per column. Something that you may have noted with that one column per interval per attribute is that if you have, once you add another level, another day, or another attribute to your data set, that can increase the size of your table immensely and make it really hard to work with. So COVID hasn't gone away in the last year or so, and we know it wasn't going to be like that, and it will still be around for a little while. So when we want to animate and map this data, we want to try to reduce the number of columns as much as possible. And the way we can do that is by just restricting our values to one column per day. And so you can see that this is the name of the column. So this is the value on August 23rd, 2020. And then the value is not a number. It's a string that separates numbers by pipe values. So the first number is the total number of cases reported to date, and the second number is the total number of deaths reported to date. And we can use Arcade to parse those values. So I can construct, based off the time slider value, I can construct the field name. That's what's happening here. And then I take that value and I split it based off that pipe character, and I can cast the number of cases as a number and the number of deaths as a number, and then I can do whatever I want with those values. In this case, I just want to know the number of deaths, so I will return that number. But you could make any number of calculations with those values, and that's what I've done with all of those attributes in that app. I can approximate the number of active cases on any given day using a formula from the CDC. I can calculate the death rate using the population or the rate of the population that is currently infected. You can do all sorts of things. So you can keep your data compact as possible while and then use Arcade to your advantage here. And like to hear from your questions. I've already said this twice, but I need to emphasize it again. Every time this slider updates, or the slider value updates, you're going to change the render using the date value. And the key thing here is that the visual variable stops or the breakpoints need to be fixed. Because if you change those, then your visualization will not make sense. You got to have a constant scale to compare between between time intervals. So the changing data variable is typically indicated by a column name that represents a date, but it could be in something else, or and the data value could represent anything. It could be population, votes, positive tests. So that's where you update the Arcade expression or the field value. All right, well, that was all we had to show you, but in conclusion, I think you can reasonably ask, how do I know which technique to use? Like, that was a dump of information, kind of a lot to digest. Well, I've condensed it down into this basic slide here. If you know that you want to animate your data, ask yourself some of these questions. Is the location updating? Is it a vehicle that I want to track, or is it a hurricane position? If that's the case, you're always going to have to filter it using the techniques that Anjul explained. But if you have other variables, say that you have administrative boundaries you manage or regional boundaries, and you want to animate data over time, then you need to use one of these other techniques. And that really just depends on your data structure. Are you working with one date value and using basically rendering based off age, or do you want to render based off some other attribute, such as active COVID cases? In that case, then you're going to use this data variable animation. We provide all the links to our demos on GitHub. I'm going to update the slide to include my GitHub repo as well. And There are other presentations we encourage you to check out about client-side queries and data visualization. But I would like to thank you for coming to this session on behalf of Andrel and myself, and ask that you please provide your feedback. You click on the link, survey link below this video, and tell us how we did as presenters, and if there's any topics that you would like to see covered in the future, and how relevant this content was to you. So with that, I would like to thank you.
Hi, everyone. Thank you for coming to our presentation today. We have lots of good questions, and my name's Enroll. The first question here, so we'll answer out your questions. So first question here is, do you have code on GitHub for these examples? Christian?
Yes, we do. Anjul and I both have a repo, and I've got separate repos for some of those apps. The COVID one, the OneOcean app. I posted the links in that as replies to that initial comment. So if you just navigate there, you can find all the links there.
Thanks, Christian. So next question is from Colin. How do you how do I use time slider for 3D multi-patch data? So I posted two links in a question where our coworker Raluca shows how to use a scene layer with a time slider. As long as your scene layer has a date field, you can use it with a time slider, and the apps I posted will show you how to use it. Also, if you have a feature layer with a multi-patch feature layer, you can use it with a time slider. Our next question is from Colin. How can you export an animation to a video format? Christian?
That's a great question. We don't have anything out of the box, no widget or utility function that allows you to record an animation that you can export to a video format. So just right off the bat, there's not anything we provide. There are things that you can develop to do that. You just need to use just JavaScript or some outside resources. And I'll try to find, I know we have an example of doing this somewhere. It's not in our documentation, so I'll have to dig it up and reach out to you later to try to find that.
Okay, so next question is, can I use time slider with time-enabled layers that have a date field? Yes, so we covered this in this presentation. You can go back and watch it. If you have a layer with a date field, but time is not enabled, then you can use it with a time slider by watching the time extent property on the time slider and setting the time extent on the layer itself. So I have a test or a demo app for this that I used for the presentation. It's called the Kincaid Fire demo. So Christian posted the link above, so you can go check it out. Okay, next question is, can we use non-hosted feature layer? Christian?
Yeah, so you can use, I mean, it really depends on the technique you want to use, right? Anjul just kind of answered a part of that question. So if it's a non-hosted feature layer, yeah, you can do it time enabled with a time slider, or even non-time enabled with a time slider. You just have to watch for different properties. The other thing to remember is the techniques I showed with changing the renderer or changing the data, pointing to the data field on the renderer or in the visual variable stops. That all of that will work just fine in a non-hosted layer.
Okay. So next question is a typical use case to put JSON object inside column. Is it for example, instead of having new cases, there's a JSON example. Can Arcade expressions parse JSON objects? Christian, you want to take this one?
Oh, that's a great question. I'm not sure. I mean, I can't really talk to whether it's typical or not. I mean, certainly the examples I showed, I don't think are very typical either. So having that pipe separated approach, I wouldn't call that typical. I just say we can do that with Arcade. But absolutely, you can do this. If you have JSON objects in your field, you can use Arcade to parse those objects. There's a dictionary function in Arcade, and you pass it to that dictionary function, and it will create basically a standard object notation within Arcade, and then you can use that, you can parse it out and return the value you want. So yes, absolutely, you can do that.
Okay, thanks, Christian. So what should my attribute table look like if I want to visualize land use over time for I think this is a good question for Christian.
All right, so this kind of, this is where I would defer to that chart or that table on the last slide of the presentation. It really depends on kind of the nature of your data. Like, are these boundaries the same or are they changing over time? If the boundaries change and they're distinct over time, then you're gonna just have like a typical attribute table where each record is a different time basically that for that feature or that land use thing. But if like the boundaries are the same, then you can kind of do this fat table approach where you add columns that show different classifications at different time intervals, or you could even put it in a single column if there's space for it to delineate like time frames using the object notation as that other person pointed out. So there's a couple of ways. It just kind of depends on the nature of the data, if the geometry changes.
Okay, so another question for you, Christian. Is there a straightforward way to use related tables as values from which to apply filters or renders on a data set?
Is there a straightforward way? I would say no. I mean, working with the related records can be tricky, but when it comes to this stuff, I mean, I just want to point out, this is a great question because I feel like this is the most common data structure, right, that we encounter. You have a layer that has geometries and maybe they're static. So again, going back to say the counties, you just have a layer of 3,500 counties. And then maybe you have a separate table that shows election results, or maybe it's COVID numbers or vaccination records. And you have multiple records for each county. This doesn't really work with that, unfortunately. We don't have a way to performantly animate data in a related table like that. We had to bring it all into like one big fat table in order to make sure that the GPU had access to all that data so we could update the renderer seamlessly in a smooth animated way. There's potential that we have, I mean, you can do this with joined tables, by the way. It's just not one-to-many related tables. There's potential that we could do something on the client for that scenario. And I think we do need to explore it some more. It's just not possible right now.
Okay. So the next question is feature service numbers limited to 1,000 by default? Do you want to take this one, Christian?
Sure. Yeah. So I'm guessing that's referring to the max record count in the service. I think it depends on I think the data source. It might be 1,000. It could be 2,000. But what that max record count means, it doesn't mean that you're limited to querying 1,000 features and displaying it in the map. So you can, let's say you have a layer that has 100,000 features and that max record count is 1,000. That just means that the queries that we execute to render all that data in the view cannot exceed 1,000. And that's fine. We have optimized our queries so that it's optimized for rendering and drawing, and we've improved the performance. So I wouldn't change that number. Personally, I wouldn't make it higher. I think it just means that that's the max amount in a patch or a page that we would query.
Okay. Next question. Is it possible to enable a layer after it's published? Yes. If you're working with a hosted feature services, then you can do that by going to your layer settings page on your org. Next question. What is updating data? Does that mean the attributes can change over time for each object? How can this be achieved? Christian, looks like maybe you replied.
Yeah, I did. So that, I mean, that could be a couple of ways. One is when I say updating data, I really mean it could be the fat table approach where I also did an election map recently that shows, the numbers for each party for each election going back 20 years or something. That's really what I mean is you have a county or you have a state and there's multiple numbers referring to the same attribute, but those numbers are different depending on the year. The number of people voting Democrat is going to change in any given location depending on the election. So that's really what that's referring to. But it could also mean like temperature values, right? In a weather data set, that temperature updates every 5 minutes or something. You just that doesn't really work in an animation because you have to have that previous data persisted. And so that's why we have that fat table approach. And someone just came up with a question right now that I can address, Anjul, if that's okay.
Okay, yeah.
Is there a limit to how fat the table can be? Like how many columns? Yes, there is. For hosted feature services, that number is 1,024 columns. So if you go beyond that, or if you have data that goes beyond that, then that approach doesn't really work. And we actually did run into that, by the way. In the COVID app, you saw it stops basically at January. We couldn't really go beyond that because there's been so many days that we're tracking this data. So I just want to point out that there are limitations there. So don't. So you just got to be aware of that.
Okay. So next question: is it possible that visual variable animations can be added as a feature for Enterprise or Pro? Christian, you want to answer that?
Sorry, can you repeat the question?
Is it possible? Okay.
Okay. Is it possible that visual variable animations can be added as a feature for Enterprise or Pro? Yeah, I mean, I think it's possible. We just need to make the enhancement request, and we need to communicate with that team. But I don't really know. I don't work on the Pro team, so.
Okay, and I'll take this next question. Does data just load to application for one time? Everything is rendered and filtered on the client side. This is true for client side layers like GeoJSON layers, CSV, and client side feature layers. And we actually had a presentation on client side analytics yesterday, and the recording will be available for you guys just a few days after, I believe, after a conference. So please check it out. So if you're working with client-side layers, yes, there will be no server-side calls once the client-side layers are loaded in browser. But if you're working with the server-side layers like a feature layer or scene layers or stream layers, then you will see calls to the server side. Okay, next question is from Nick. Please explain for dummies, if I have a date field and evaluate this data via filter or visual variable, it seems like a complete picture. What does time enable actually do? So if you have a layers with a time info property published with it, then you can add the data to your application. And for the time slider, you can just set the view property on the time slider, and the view will take care of the filtering out the data that doesn't fall within the current extent of your time slider. If your data doesn't have time info, then you as a user have to listen to the time extent property change on a time slider, and you as a developer are in charge of filtering out the data that does not fall within the current time extent of your time slider. All right.
Yeah. The difference basically is how much code do you want to write. If you have it time enabled, the widget and view take care of it for you. If it's not, then you just have to write the logic for it.
All right. So it looks like we still have a few more questions. Before I read the next question, I want to point out the session will be ending in 2 minutes. We will reply to you guys here. But if you didn't reply to your messages or you didn't get the answer, please come and find us on Ask Our Experts channel in a web development part. We will answer your questions over there, okay? So the next question is, this is not JavaScript. How do you get the 3D effect for contiguous US? Christian?
Oh, so that must be in the COVID app. That's actually a layer effect, on a drop shadow layer effect on the whole layer. So it's just a simple property you set there. That was released that's a pretty recent function. I think that was released. So
there is actually a session right after this for effects and blend mode. So if you want to learn how to set those effects, come and find us in that session in 2 minutes or in 15 minutes, sorry. All right, sorry to cut you off. Okay, next question, Christian. Can this be a live or near live data animation?
I don't know. I guess I'd have to see I mean, I'm not sure. I mean, I think that these techniques really lend themselves to data that's persisted from the past. So I'm not sure how successful it would look for a near live scenario. Like I think that stream layer, if that's what you're referring to,
Yes.
like streaming in features, is more appropriate for that scenario. So it's not, that's a slightly different case where you're watching for those. Yeah.
Okay, so one last question, probably before we finish this session. Would there be a need for having a specific time-enabled feature where the geometry never changes? That may allow all those cool animation to be used in dashboards and web app builder app without custom code. I would love to have those effects out of the box.
Okay, would there ever be a need for having a specific time-enabled feature? I'm not totally sure I understand
Okay.
the question, but we can answer this after the session. I think if we sit down and just kind of talk it through. So yeah, I mean, yeah. So I mean, this kind of is similar to having out of the box features in Pro or Dashboard. That is something that we can talk about, and we do. There was an example of an app template that we built where this was all built in. So I can point you to that resource. But yeah, we just need to get buy-in from these other teams as well.
Yeah, so that's all we have time for. Thank you so much for coming to our presentation. But again, if you didn't have a chance to answer your question, please come and find us in the Ask Our Experts channel, web development channel. Okay, we will be there to answer your questions. Have a good day and thank you.
Thank you, everyone.